everyone, in this video I'm going to solve this algebraic equation. The equation we have x plus 2 whole to the power of 6 is equals to 2 to the power of 12. Here we need to find out the value of x. So let's get started the solution. In the first step, I will going to split the powers. So x plus 2 whole to the power of 3 times 2 is equals to 2 to the power of 2 times 6. Now, in the next step, we're going to apply the exponential rule, that is a to the power of m times n can be written as a to the power of m and whole to the power of n. And we can write this also a to the power of n and whole to the power of m. So I'm going to apply this here. So this equation turns to x plus 2 whole to the power of 3 and raised to the power of 2 is equals to, and this will be equals to 2 to 10 divides 4 to the power of 6. Now 6 I'm going to split here 3 times 2. Now in the next I'm going to express this in this form. So the next question we'll get, that is x plus 2 whole to the power of 3 and raised to the power of 2 is equals to 4 to the power of 3 and whole to the power of 2. Next, I will going to take this 4 to the power of 3 and whole to the power of 2 to the left hand side. So here we will get x plus 2 whole to the power of 3 and raised to the power of 2 minus 4 to the power of 3 and whole to the power of 2 is equals to 0. Now, in the next step, I'm going to apply the algebraic identity, that is a square minus b square can be written as a plus b, a minus b. We have this is a and b value, so this equation turns to x plus 2 whole to the power of 3 plus 4 to the power of 3. X plus 2 whole to the power of 3 minus 4 to the power of 3 is equals to 0. Now here we get the two cases. This is our case 1 and case 2. Now we're going to solve it out case 1. The case 1 we have x plus 2 whole to the power of 3 plus 4 cubed is equals to 0. Here I will going to apply the algebraic identity, that is a cubed plus b cubed can be written as a plus b, a square minus ab plus b square. This is a and b value. This equation turns to x plus 2 plus 4, a plus 2 whole to the power of 2 minus ab, x plus 2 and this 4 plus this 4 square is equals to 0. Now we're going to simplify it further, so it will equals to x plus 6. Now here I'm going to apply another algebraic identity, that is a plus b whole to the power of 2 can be written as a square plus b square plus 2ab. So this is our a and b value, and this can be written as x square plus 4 plus 4x. This will be equals to minus 4x, and here minus plus minus 8 plus 4 times 16 is equals to 0. Here this positive and this get cancelled, so the next question we will get, that is x square, and this will be equals to positive 12. So the next question we will get, here we get x plus 6 and x square, here positive 12 is remaining, is equals to 0. Here we get the again two cases, x plus 6 is equals to 0. X is equals to this, I'm going to take to the right hand side, so we will get this negative 6. So this is our first x value. Now we're going to solve it out this. X squared plus 12 is equals to 0. Now here I will going to take this 12 to the right hand side. X squared is equals to negative 12. Now I want to remove this square, so I'm going to take root both this side. So here this and this get cancelled. X is equals to plus minus root 12. Now from here I want to separate this negative sign from 12. So I'm going to write x is equals to plus minus root 12 times negative 1. Here I am going to apply the radical rule, that is n root of a times b can be written as n root of a times n root of b. So here this will be equals to x is equals to plus minus root 12 and root negative 1. And as we know that root negative 1 is equals to iota, so this equation turns to x is equals to plus minus root, in replacement of 12, I'm going to write 4 times 3 times iota. And now the root of 4 we have x is equals to plus minus 2 root of 3 iota. Here we get the two x values. X2 I'm going to name it 2 root of 3 iota. X3 we have negative 2 root of 3 iota. Now next I'm going to solve it out this case too. The equation we have x plus 2 whole to the power of 3 minus 4 to the power of 3 is equals to 0. Now here I will going to apply the algebraic identity, that is a cube minus b cube is equals to a minus b, a square plus ab plus b square. Here this is our a and b value. So this equation turns to x plus 2 minus 4, x plus 2 whole to the power of 2 plus x plus 2 times 4 plus 4 to the power of 2. And this will turn to x and plus minus minus 2. And here I will going to apply the same algebraic identity, that is a square plus b square plus 2ab. So this is our a and b value. So this will turn to x square plus 2 square root of 2 we have 4 plus, and here 2ab is equals to here 4x plus this I'm going to multiply. So it will be equals to 4x plus 8 plus this 4 times is 16 is equals to 0. And this will be equals to x plus 2 and here x square. This I'm going to solve it out, so it will be equals to plus 8x plus 4 plus 8 and plus 16 equals to 28 is equals to 0. Here we get the two cases, x plus 2 is equals to 0 and this will be equals to x is equals to negative 2. So this is our fourth x value. Now we're going to solve it out this case. X squared plus 8x plus 28 is equals to 0. Here we have the ABC's value, that is 1, and this is B value 8, and the C value we have 28. Now I was going to solve it out this by plugging the ABC's value in the quadratic formula. X is equals to minus, and B we have 8 plus minus root 8 square minus 4, 1, and C we have 28 over 2 and 1. X is equals to minus 8 plus minus, and this will be equals to 64, and 428 times there was 112 over 2. X is equals to minus 8 plus minus this will be equals to, and here 64 minus 112, so here we will get negative 48 over 2. Now in the next step, I want to separate this negative sign with this 48, so I'm going to express x is equals to negative 8 plus minus root 48 times negative 1 over 2. Now I'm going to apply here the radical rule, and I'm going to express this separately. Minus 8 plus minus root 48. I'm going to write here 16 times 3 times root negative 1 over 2. X is equals to negative 8 plus minus the root of 16. We have 4 root of 3. And the negative root of 1 is equals to iota over 2. In the next step, here we're going to take the common factor of 2. X is equals to 2 negative 4 plus minus 2 root of 3. Iota is remaining over 2. Here this and this get cancelled. So this is our 2 more x value we'll get. Negative 4 plus minus 2 root of 3 iota. So here we get the 2 more complex solution. So this is the final answer. Thank you so very much for watching my video. If you like my video, please do subscribe to my channel.